So today we're doing 710, perimeters and areas of similar figures. And with this actually comes up in the Math 8 as well. So if you can master it now, next year you'll just fly right through it. I found there's a lot of people in my Math 8 class that struggled with this. And really it comes down to either learning two equations or being able to kind of hack through it and figure it out as you go. So you're welcome to kind of draw out the things that I'm doing if you want to, or you could just kind of look. But for me, sometimes it's helpful to be able to see kind of what's going on with something. But before we really do any drawing, if you wanted to, you could try to define like perimeter, or I guess you guys all good on perimeter and area. Perimeter is the
distance around a figure.
Perfect. Distance around a figure, and area is the
Inside the figure.
yeah, kind of like that space inside, although space sounds a little bit like volume to me. Okay, so perimeter, distance around, areas of space inside. So I'm going to start by trying to explain it kind of this way. If I were to just draw an object, and I'm going to aim to be on the line, sometimes it's a little bit hard with my little stylus. But if I have something like this, and you could draw it, you could skip it, it's up to you. But this is going to be a 2 by 3, fair enough? So I just have this 2 by 3. So now the perimeter of this thing is going to be what? 10. Because we have 2 plus 3 plus the 2 over there plus the 3 over there for a total of 10, right? Or you could do 2 times the base plus 2 times the height. That works also. We have that. And now what I want to say is, all right, I'm going to do a scale factor of 2 to that. Now, instead of it being 3 wide, if I do a scale factor of 2, it's now going to be how wide? 3 times 2 is... Yeah, so a scale factor of 2 just means we double it. So we have 2, 4, 6. So now we have something that's 6 long. 1, 2, 3, 4. Yep, 6. And instead of being 2 high, it's going to be 4 high, because I'm doubling it. So the 2 times 2 gives me 4. So now I have something that's 4 by 6. So the new perimeter here is going to be 20. Yep, because I have 4 plus 6 plus 4 plus 6 for a perimeter of 20. You still tracking with me? Okay. If I were to instead, I'm going to try to squeeze it down below. I'm going to say, take my original, and I'm going to do a scale factor of 3. So I'm going to still start with that like same 2 by 3. And I want to make it 3 times as big. So instead of being 6 long, it's going to be 9 times. So 3 times 3 gives me 9. Good call. So 2, 4, 6, 8, 9. Instead of being too tall, it's going to be 2 times 3, so 2, 4, 6. So now I have this thing here that's going to be a 6 by 9. So in some respects, well, I should finish this. So a new perimeter is going to be 30. Because 6 plus 9 plus 6 plus 9 gives me 30. You tracking with me? And if you forget the equation we're about to come up with, you totally can figure it out just from like doing the problem kind of like this when you get to the quiz or test. But if you remember the equation, it's faster. All right, so if I had a perimeter of 10, when I do my scale factor of 2, it becomes a perimeter of 20. I had my perimeter of 10, I did my scale factor of 3, it becomes a perimeter of 30. So what do I do to my original perimeter to find the new one? So you'll notice then, scale factor of 2, you just double it. Scale factor of 3, you triple it. So if you wanted to write the new equation, you could say something like the new perimeter equals the original perimeter times, I'm just going to do F period, S period, F period. You can put it in parentheses if you wanted to, so it all looks like one thing. But you just take the original perimeter, multiply it by your scale factor, and you're done. Yes? So if you can remember that there in purple, it'll save you a bunch of time when you see this one on the test. The other way you could use the same equation is to say we're trying to find that scale factor, so kind of another application. Say instead of knowing the scale factor, I give you 2 drawings like this up at the top, where I say the perimeter was this, the new perimeter is this. What's the scale factor? Well, if I wanted to take my equation and get scale factor by itself, I wouldn't mess up your equation, but this is multiplied, right? So if I want to get scale factor by itself, I'd have to divide by that original, and I wouldn't do this if I were you, divide by the original p on both sides, and I'll back up like 20 times. So you could say the scale factor then equals that new perimeter, new capital P, divided by the original perimeter. So you could either find the new perimeter with that top equation, or you could find the scale factor with the second equation. Feel like you know enough to be dangerous?
Sure.
Okay. We're halfway. I'm going to try to just reuse my pictures up here, though, instead of like going back and doing the thing over again. So you could try to draw the same thing, or maybe I'll just switch to like a different color. Let me see what colors I have to work with here. Go for like an orangish. All right, area. Say I'm looking at my original one here. What's the area of this original one right there?
John, let's try this out. 6.
So it has to be a 6 because we do 2 times 3 to get the area. Agreed? 2 times 3? Then, or you could count little boxes, I suppose, in this case. Area of this new one after a scale factor of 2, the new area of this one here is going to be 24. You do the 4 times 6, so 24. Well, so what do you do to 6 to get to 24?
Times it by 4.
Times it by 4. So when our scale factor is 2, we have to multiply the area by 4, yes? Any guesses what you do to the area when your scale factor is 3 right there? Now we're going to multiply by,
5.
well, we could always try it. So I have this extra line here. So we just have, all right. Okay, so now with this one here, area is going to be the 6 times 9. So area is 54. So 6 times what gives you 54? 9. So we just took and multiplied the area by 9. So when the scale factor is 3, you multiply by 9. When the scale factor is 2, you multiply area by 4. How could you change a 2 into a 4 and a 3 into a 9?
Times them by themselves.
Times it by themselves, which is the same as saying we square them, yes? So the last two equations would be the new area equals the original area, capital A for area, times, I'm going to do my little scale factor there in parentheses, just shows one thing, but we have to square it. And if you wanted to, you could say the last but not least. If we wanted to write scale factor from the area, you could say, well, scale factor equals. Well, now we have to do two things because we have to get rid of this original area and we have to get rid of this squared there. So it ends up being new area divided by original area. And if you leave a little space between the equals in this, so the new A divided by the original A. Dividing that is going to take this top equation here and get it so it's scale factor squared equals this fraction. But I want to get rid of the squared and just have scale factor. So to get rid of the squared, we'd have to square root as well. But this is the equation you could use to find the area of something. And that's it for the section. Actually, really, that's it for the chapter. Any questions?